Hello. I was watching another Math Sorcerer video in which the Math Sorcerer um, solved this equation in brackets x minus 1 close brackets y double prime plus y prime equals 0. Um, he solved that using series, and that video can be seen at this web address. Now, it happens that this equation can actually be solved by a different method, kind of a more analytic method if you want, by using a substitution or two. You might have seen my previous videos in which I do just this, particularly with non-linear ordinary differential equations, and it's basically the same method and the same process for this equation, equation 1. So what we're going to do is we're going to let u equals y prime. And this means that du by dx is equal to y double prime. So we can now substitute in u for y prime and du by dx for y double prime. So let's go ahead and do that so that we get x minus 1 du by dx plus u, and that's equal to 0. And I'll just double check that I've got the signs right. Yeah. And we'll call that equation 2. Okay, right, now then we can simplify this equation. And what we get is, well, we'll keep the x minus 1 on this side, du by dx, and we'll move the plus u to the other side of the equal sign over here and write it down as minus u. Now, this is an equation in which we can separate the variables. So I'll just write that down, separating the variables. Right, we get du over u, and that's equal to minus dx over x minus 1. And of course, when we separate the variables, we put in the integral signs. And first of all, let's be consistent. We'll call the equation above equation 3. And so this equation that we've just written down, we can call equation 4. Right? So this is very easy to integrate. And what we get is the log of u, and that's equal to minus the logarithm, these are natural logarithms, of x minus 1 plus, there's a constant of integration, and for reasons that hopefully will become clear, I'm going to call it the log of constant c rather than just the constant c. And that's because it's easier to manipulate everything in terms of logarithms rather than if we just call this whole constant here c on its own. So the logarithm of c is easier to deal with. Now, I'll just rewrite this. There's really two ways of simplifying the right-hand side, but I'll rewrite it and simplify it doing it this way. So I'm just swapping around the terms. And by the laws of logarithms, we can write the right-hand side as the logarithm of c over x minus 1. So if that had been a plus there, we would have had the logarithm of the whole of c times x minus 1. So we'd have had the logarithm of the product of c and x minus 1. Because we've got a minus sign here, we've actually got the logarithm of c divided by x minus 1. And that simplifies. Shall we give that equation a name? We call it equation 5. So that's equation 5. And taking the antilogs of both sides, I'll just write that down. Taking antilogs, or the exponential of both sides, we get u equals c over x minus 1. And I'm just going to verify that I have written that down correctly. So taking the exponential of both sides, or the antilogs of both sides, we get u equals c over x minus 1. And I'm actually just going to write that a little neater. Minus 1. Right, there we are. Now, we know, because we defined this at the beginning, we know that u equals dy by dx, right? Because that was our original substitution. I'll just go to the top and highlight that. So we actually said here, let u equals y prime, or in other words, let u equals dy by dx. So we can now substitute, and we want to give this equation a name. So we'll call it, I think we call it equation 6. Let me just scroll back neatly. So if we call this equation 6, then equation 6 becomes, just write it down, so equation 6 becomes dy by dx equal to c over x minus 1. And we'll call that equation 7. Right? Now we can separate the variables again. So separate the variables in equation 7 to get the integral of dy is equal to c times the integral of dx over x minus 1. And we'll call that equation 8. Right. Now we can integrate this again very, very easily. So we get, or rather I should put, therefore, y is equal to c times the natural log of x minus 1 plus d. D is another constant of integration. And we just leave it as d. There's no point in putting it as log d, because log d is still a constant of integration. And that basically is our general solution. Therefore, the general solution is y. Let me just make a little more space to finish that off. So I'm going to rewrite the constants. Is y equals a plus b log x minus 1. I've just fiddled around with the constants. I've called c, b, and d, a. And it doesn't really matter what you call them, because whatever the initial conditions are, they will come out with specific numerical values, whatever they are. So that is a general solution, and that's basically how it is done, and that concurs with what the Math Sorcerer obtained himself in terms of series. So I hope you've enjoyed that video, and that you will come back, give me the thumbs up as they say, and I shall see you in the next video. So thank you very much for watching, and bye for now. Bye.